Analytic function. A function f of z is said to be analytic at a point z0 if it is differentiable at z0 and also at each point in some neighborhood of z0. This function is also known as regular function or holomorphic function. So this is the definition for analytic function. Okay, now next is Cauchy-Riemann equations, CR equations. Simply we can say CR equation. The equations dou u by dou x equal to dou v by dou y and dou u by dou y equal to minus dou v by dou x are called Cauchy-Riemann equation. Simply we can say ux equal to vy and uy equal to minus vx. So this is Cauchy-Riemann equations. Okay, now next polar form of CR equation. The polar form of CR equation is the CR equation involving r and theta. That is dou u by dou r equal to 1 by r into dou v by dou theta and dou v by dou r equal to minus 1 by r into dou u by dou theta. So this is polar form of CR equation. Simply we can say ur equal to 1 by r into v theta and Vr equal to minus 1 by r into u theta. So this is polar form of CR equation. Next, sufficient condition for f of z to be analytic. Okay, so now suppose that the real and imaginary parts u and v of the function f of z equal to u plus iv are continuous and has continuous first order partial derivatives in a region R. If u and v satisfy CR equation, then f of z is analytic. That means to verify f of z analytic, it is enough to verify CR equation. So if u and v are satisfied CR equation, then we can say f of z is analytic. Okay, so this is very simplest method, easy way to verify the function f of z is analytic. Just enough CR equations are satisfied. Okay, now next harmonic function. A real function u of two variables x and y is said to be harmonic function in a region R if it has continuous second order partial derivatives and satisfies Laplace equation. That is dou square u by dou x square plus dou square u by dou y square equal to 0. That is uxx plus uyy equal to 0. So if the function is harmonic, if u is harmonic, then it should satisfy CR equation. It satisfies Laplace equation. That is uxx plus uyy equal to 0. Prove that f of z equal to z cube is an analytic function. Okay, so to prove the function f of z is analytic, the function should satisfy CR equation. Okay, so that I am going to verify with the CR equation. So the given function is f of z equal to z cube, but z is x plus iy. So that this is x plus iy the whole cube, and the f of z is always u plus iv. Okay, so now to find u and v, I want to apply a plus b the whole cube formula. So what is the formula for a plus b the whole cube? A plus b the whole cube equal to a cube plus 3a square b plus 3ab square plus b cube. So this is the formula for a plus b the whole cube. Okay, so by using this formula, so this is a and b. So a plus b the whole cube. So a cube plus 3a square b plus 3ab square plus b cube. Okay, so now x cube I can take here, so I into 3x square y, and this is I square is minus 1, so minus 3x y square I cube. So listen, I cube is minus I. Okay, so that I cube is minus I into y cube. So this is u plus iv. Okay, now to find the values of u and v, equating the real and imaginary part. So equating the real and imaginary part. Okay, so now the first real part is u. So here the real parts are x cube minus 3xy square. So this and this are real part. Next, imaginary part. Imaginary part is v. So here the imaginary parts are this and this, I coefficients. So 3x square y minus y cube. Okay, so after obtaining u and v, now I want to verify with the CR equation. For the CR equation, I want to find out ux, uy, etc. Okay, first I am going to differentiate partially with respect to x. This is ux. So what is differential partially with respect to x? X cube differential 3x square. Here x differential is 1, so minus 3y square. And partial with respect to y, uy equal to, this is 0, this is 2y. 2y means 2 3 is 6, so minus 6xy. And now here partially with respect to y, x, vx. So this is 6xy and there is no x, leave it. And now next vy. Vy is equal to, with respect to y, 1 into 3x square minus 3y square. Okay, so now I want to compare with the CR equation. So what is CR equation? CR equation is ux equal to vy, uy equal to minus vx. So this is for CR equation, Cauchy-Riemann equation. I want to compare with the Cauchy-Riemann equation. You see ux must equal to vy. So always you compare with this and this. The logic is this and this must be equal. So that is ux equal to vy. So you see 3x square minus 3y square, 3x square minus 3y square. So from this ux is equal to vy. So from this ux equal to vy. And then next to uy, what is uy? This is uy. Uy is equal to minus vx. This is vx. So by comparing here, sign will be different. Actually that is a procedure. Uy is positive mean another one is negative. So this is a procedure. So one is positive, another one is negative. Then it will be true. So therefore the second one is uy is equal to minus vx. That is here negative mean that is positive. If it is positive mean that will be negative. So minus vx. Therefore both the conditions are satisfied. Therefore CR equation satisfied. Therefore CR equation are satisfied. Therefore f of z is an analytic function. Hence proved. Second problem, check whether the function f of z equal to e power of x cos y minus I sin y is analytic. Okay, to verify it is analytic, I want to verify with the CR equation. Okay, so here the given function is f of z is equal to e power of x into cos y minus I into sin y. Okay, now f of z is always u plus iv. So this is, you can multiply e power of x inside. So e power of x into cos y minus I into e power of x into sin y. Okay, equating the real and imaginary part. Equating the real and imaginary parts. Okay, so by equating the real part, u is the real part. Here correspondingly the real part is e power of x into cos y. And the imaginary part is v. Correspondingly here the imaginary part is minus e power of x into sin y. Okay, So from this I am going to find out ux. Ux is partial derivative with respect to x. E power of x differential e power of x cos y. And then I want uy, partial derivative with respect to y. So e power of x into cos y differential minus sin y. Okay, from this I am going to find out Vx, partial derivative with respect to x, so minus e power of x sin y, and Vy, so minus e power of x into sin y differential cos y. Okay, now I want to verify with the CR equation, but in our previous problem already I discussed the CR equation. So the CR equation is these two terms must be equal. But you see here e power of x cos y, but here this is minus e power of x cos y. Both are unequal. So here ux is not equal to vy. Therefore CR equation not satisfied. Therefore f of z is not analytic. Not analytic function. Okay. Third problem. Verify the function f of z is equal to e power minus x cos y minus I sin y is analytic. Okay, here the given function is f of z is equal to e power minus x into cos y minus I sin y. Okay, so but f of z is u plus iv, which is equal to multiply e power minus x inside, so e power minus x into cos y minus I into e power minus x sin y. So next equating the real and imaginary parts on both sides. So from the real part is u is equal to e power minus x into cos y, and the imaginary part is v is equal to minus e power of minus x into sin y. Okay, now to verify with the CR equation, I want to partial derivative with respect to x and y. So first I am going to partial derivative with respect to x, ux. E power minus x differential minus e power of minus x into cos y, and uy is cos y differential minus sin y, so minus e power of minus x into sin y. And then from v I want vx, partial derivative with respect to x, so e power minus x differential minus e power of minus x, but already is here minus of minus plus, so e power minus x into sin y. And then next I want vy, so minus e power of minus x into differential of sin y is cos y. So everything over. Now I am going to compare with the CR equation. But the CR equation ux must equal to vy. But you see both are equal. So from this ux is equal to vy. And uy must equal to negative of vx. You see, so here both are different signs. This and this same but different sign. So that it is satisfied. Uy is equal to minus vx. So CR equation satisfied. Therefore CR equations satisfied. Therefore f of z is an analytic function. Okay, so verification over. Show that the function f of z is equal to log z is analytic everywhere except at the origin. Okay, now the given function is f of z is equal to log x. It is something different function. So that I am going to use polar form of CR equation. What is polar form of CR equation? The polar form of CR equation is ur is equal to 1 by r into v theta, and vr is equal to minus 1 by r into u theta. So this is the polar form of CR equation. So I want to verify with this. Okay, so here, so generally z is equal to x plus y. To convert into polar form, the polar form of x plus iy is r into e power I theta. So this is the corresponding polar form of x plus iy. So that in this problem I am going to put z equal to r into e power I theta, because generally r z is equal to x plus iy, but I want to convert the problem in terms of polar form r into theta. Therefore x plus iy corresponding value is r into e power I theta. So here z is equal to r into e power I theta. Okay, substitute in the above equation. At the same time f of z is u plus iv. So u plus iv for f of z, which is equal to log of z is r into e power I theta. Okay, but we know this is considered m, this is n, log mn. What is the formula for log mn? Log m plus log n. Okay, and now log r plus m power n. What is the log m power n? The power n can take in the here. So I theta into log e. But you see log e value is 1. Since log e value is 1, so here u plus iv is equal to log r plus I theta only. Okay, now I am going to equating the real and imaginary part. By equating the real and imaginary part, u is equal to log r, real part, and v is equal to imaginary part is theta. So I want ur, vr, u theta, v theta to verify CR equation. So that from this ur, partial derivative with respect to r, log r differential is 1 by r. And u theta is equal to, here there is no theta, so partial derivative is 0. And vr, here there is no r, it is 0. And v theta is equal to theta differential is 1. So now I want to verify CR equations. So first I am going to verify with the first CR equation. What is first CR equation? ur, take ur. Are you clear? First CR equation I am taking ur. From this ur I want to equate with 1 by r v theta. So what is ur? Ur is 1 by r. Okay, ur is 1 by r. Every 1 by r, the term can be written as multiple of 1. So this term can be written as 1 by r into 1. Are you clear? Any number can be written as multiple of 1. Similarly, this 1 by r I can write into 1. But you see 1 by r, 1. This 1, what is 1? 1 is v theta. So v theta. So you see ur is equal to 1 by r v theta. So first equation is verified. Ur equal to 1 by r v theta. So that first equation verified. And now next equation I am going to verify. So for the second equation I want VR. What is VR here? This is VR. So VR is equal to 0. But this VR must be equal to minus 1 by r into u theta. Okay. So you see generally 0 can be written as multiple of any term. So any 0, this 0 can be written as minus 1 by r into 0. Why? Because when you multiply these two, this becomes 0. So that 0 can be written as multiple of any number. So here I am going to take 1 by r. Okay, now you listen. Minus 1 by r into 0. What is 0? 0 can be this or this. But what we want to prove? U theta. So for 0, I can write u theta. So for 0, 0 is u theta. So 0 is u theta. So second equation also verified. VR is equal to minus 1 by r into u theta. So that second equation also verified. Therefore CR equation is verified. Therefore CR equations are satisfied. Therefore f of z is equal to log z is analytic everywhere. But you see, it is not analytic at z equal to 0. because I want to verify it except is the origin. Except origin means it's not analytic at R, because you see when R is equal to 0 it is not satisfied, it not defined. When R equal to 0, 1 by R 0 is infinity. Therefore f of z is analytic everywhere except R equal to 0. R equal to 0 means z equal to 0. That is z equal to 0. So f of z is analytic everywhere except z equal to 0. That is called origin. Therefore f of z is analytic everywhere except origin. So hence proved. Fifth problem. Examine whether the function f of z equal to z power n is any positive integer, is analytic. So I want to prove f of z is equal to z power n is an analytic function, where n be any positive integer is very important one. Okay, for any positive integer z power n is analytic. Okay, to prove this, here also I am going to use polar form of CR equation. So I am going to verify polar form of CR equation again. So okay, what is the given function? The given function f of z. The given function f of z is z power n. So here I am going to use polar form. So put z is equal to r into e power I theta. Okay, r into e power I theta. Substitute in the above function. So again f of z is u plus iv, which is equal to z value. Z value is r into e power I theta the whole power n. Okay, now when you take power n inside, r power n into e power I n theta. You see e power n theta means when you take power e power I theta the whole power n is e power I n theta. So this is as usual form. Okay, but you see e power I n theta is cos n theta plus I sin n theta. But this side u plus iv. Now I am going to equating the real and imaginary part. By equating the real and imaginary part, real part is u is equal to r power n cos n theta, and here equating the imaginary part, v is equal to r power n sin n theta. Okay, so now I am going to partial derivative with respect to x. So with respect to r, because I am going to apply polar form of CR equation. So ur mean partial derivative with respect to r. So r power n differential n into r power n minus 1 into cos n theta. But next I want u theta. U theta is partial derivative with respect to theta. So r power n into cos n theta differential is minus sin n theta into n. So this is with respect to theta. And here VR is r power n into r power n minus 1 into sin n theta, and v theta is r power n into cos sin n theta is cos n theta into n. So derivative over. Now I want to compare with the polar form of CR equation. So what is polar form of CR equation? ur is equal to 1 by r into v theta, vr is equal to minus 1 by r into u theta. So this is I want to verify. Okay, now first I am going to take ur. What is ur? Ur is equal to n into r power n minus 1 into cos n theta. So this is ur. Okay, this is I want to equate 1 by r v theta. Okay, listen carefully. You see r power n minus 1. This r power n minus 1 is r power n into r power minus 1. What is the meaning of r power minus 1? It is 1 by r. So 1 by r. What are the remaining term? What are the remaining term except 1 by r? 1 by r remaining term is n into r power n into r power n into cos n theta. Okay, but I want v theta. So you compare with v theta. Where is v theta? This is v theta. n into r power n cosine theta. So this is v theta. So that 1 by r v theta. So ur is equal to 1 by r v theta. So that first equation verified. Next I am going to compare with the second equation. What is Vr? Take Vr. So Vr is equal to, where is Vr? This is Vr. N into r power n minus 1 into sin n theta. Okay. But I want minus 1 by r. So okay, r power minus 1 is 1 by r. But I want minus 1 by r. Okay, we will see later. What are the remaining terms when you take 1 by r outside? N into r power n sin n theta. Okay, but you see I want minus 1 by r outside, but unfortunately here I have only 1 by r, so that multiply outside minus, multiply minus inside, it will be composite, minus of minus plus. Are you clear? Now this is 1 by r minus 1 by r into, what is this? This is compare with the u theta. Where is u theta? This is, we can compare, minus n r power n sin n theta. So this is equal to u theta. So this is u theta. So Vr is equal to minus 1 by r into u theta. So second equation also verified. Therefore CR equation is verified. Therefore CR equations are satisfied. Therefore f of z is an analytic function. Hence proved. Find the values of a and b such that the function f of z equal to x square plus ay square minus 2xy plus I into bx square minus y square plus 2xy is analytic. So the function is analytic means I want to find out the values of a and b. So consider the function is analytic, so it should satisfy CR equation. So by using the CR equation we can find the values of a and b. Okay, so here the given function f of s is equal to, f of z equal to x square plus ay square minus 2xy plus I into bx square minus y square plus 2xy. Okay, so now here f of z is u plus iv. This is f of z is u plus iv. So by equating the real and imaginary part, u is equal to x square plus ay square minus 2xy, and the imaginary part v is equal to bx square minus y square plus 2xy. Okay, now for the CR equation I want to find out ux. So ux is 2x minus 2y, uy is equal to 2ay minus 2x, and vx is equal to 2bx plus 2y, and vy is equal to, with respect to y, minus 2y plus 2x. Okay, so by the CR equation, what is the CR equation? CR equations, ux equal to vy and vx equal to minus uy. Okay, so ux, what is ux? So 2x minus 2y is equal to vy is minus 2y plus 2x. Okay, it is equal. So from this we are not getting any value for a and b. Okay, now vx, but where is vx? This is vx. 2bx plus 2y is equal to minus uy. Where is uy? This is uy. 2ay minus 2x. Okay, so 2bx plus 2y equal to, take multiply, minus 2ay plus 2x. Okay, now comparing the coefficient of x and y. First I am going to compare with the coefficient of x. So what is the coefficient of x here? 2b is equal to x coefficient is 2. From this b is equal to 1. Okay. And now by the comparing the coefficient of y. Coefficient of y. By comparing the coefficient of y coefficient is 2. Here y coefficient is minus 2a. From this a is equal to 2 by minus 2. So a is equal to minus 1. So the values of a and b, a is minus 1, b is plus 1. This is the answer. Show that modulus z square is not analytic at any point. So consider the given function be f of z. So f of z is equal to modulus z the whole square. So here put z equal to x plus iy. So f of z is always u plus iv. So u plus iv is equal to modulus x plus iy the whole square. So modulus means root of x square plus y square, and this is square, so whole square. So when you take square, root will be cancelled, so x square plus y square. Okay, now equating the real part and imaginary part. By equating the real part, u is equal to x square plus y square. But the imaginary part, there is no imaginary part here, it is 0. So ux is equal to 2x, uy is equal to 2y. But here vx is equal to 0, vy is also 0. So from this ux is not equal to vy. So that ux is not equal to vy. CR equation not satisfied. Therefore CR equation not satisfied. Therefore f of z is not analytic. Verify whether the function f of z equal to sin z is analytic. Okay, so here the given function is f of z equal to sin z. Okay, so now put z equal to x plus iy. So as usual f of z is u plus iv and sin of z is x plus iy. But we know the formula for sin a plus b. The formula for sin a plus b is sin a cos b plus cos a sin b. Here a is x, b is iy. Okay, but you see here one important formula. This is hyperbolic function. This is not in the syllabus of Anna University, but you should know the formula. The formula is cos ix is cos hx, but sin ix is I sin hx. So this is an important formula. These two formulas are very important in hyperbolic function. So here I am going to use cos iy. Cos iy is cos hy. So that it is sin x into cos hy by using the first formula plus cos x into sin iy. What is sin ix? I sin hx. So put I here, I sin hy by using the second formula. This side u plus iv. So these two are very important formula using this. And now I am going to equating the real and imaginary part. By equating the real part, u is equal to sin x cos hy, and equating the imaginary part, v is equal to cos x into sin hy. To To verify the CR equation, I want to differentiate partially with respect to x and y. So ux partial derivative with respect to x sin x differential is cos x into cos hy. And then I want uy cos hy differential. You see, this is hyperbolic function. The derivative of cos hy is only sin hy. So this is also in formula for hyperbolic function. Derivative differential of cos hx is only sin hx. This h represent hyperbolic function, don't treat as constant. And differential of sin hx is a cos hx. So no negative term will come here. Okay, so here uy means cos hy differential is only sin hy. So sin x into sin hy. And now here Vx is cos x differential minus sin x into sin hy. And Vy partial derivative with respect to y sin hy differential cos hy. So cos x into cos hy. So now the differential part is over. Now I am going to verify the CR equation. The CR equation is ux is equal to Vy. Compare ux and Vy. Cos x, cos hy, cos. So these two are equal. So from this, ux equal to Vx. Ux is equal to Vx. So first CR equation satisfied. And now next I am going to compare these two. Only sign will be different. So sin x sin hy minus sin x sin hy. So this is also satisfied. And uy Vx is equal to minus uy. Only difference in sign. So this is also okay. So CR equation satisfied. Therefore f of z is analytic. So CR equation are satisfied. Therefore f of z is analytic. Verify whether the function u is equal to x cube minus 3xy square plus 3x square minus 3y square plus 1 is harmonic. Okay, first condition for harmonic. Condition for harmonic function. Is uxx plus uyy equal to 0. So this is condition for harmonic. The name of the equation is Laplace equation. Laplace equation. That means harmonic function mean it should satisfy Laplace equation. So this is Laplace equation. Okay. So this is the condition for harmonic function. Okay. So now the given function is u is equal to x cube minus 3xy square plus 3x square minus 3y square plus 1. So now I want to differentiate partially with respect to x. So ux is equal to 3x square minus 3y square plus 6x. And with respect to x again, uxx is equal to 6x. This is 0. This is plus 6. So next I am going to differentiate with respect to y. Uy. So here 2y. So 2 means 6 minus 6xy. Here 0. This is minus 6y. Once again with respect to y. So uyy is equal to minus 6x. With respect to y is minus 6. So we found uxx and uyy. I am going to add these two. Therefore uxx plus uyy. Uxx is 6x plus 6 and uyy is minus 6x minus 6. So is it equal to 0? So uxx plus uyy equal to 0, satisfying Laplace equation. Therefore u is an harmonic function. Is a harmonic function. Hence proved. So 10th problem, prove that u is equal to e power minus y cos x and v is equal to e power minus x sin y satisfies Laplace equations, and but that u plus iv is not an analytic function of z. So first I want to prove both are satisfies Laplace equation. Okay, so first I am going to take u. U is equal to e power minus y into cos x. So I want ux, partial derivative with respect to x. Here only x. Cos x differential is minus sin x. So minus e power minus y into sin x. Cos x differential minus sin x. And then I want uxx. So once again with respect to x. So minus e power minus y into sin x differential cos x. And now next I am going to differentiate with respect to y. So e power minus y differential minus e power of minus y into cos x. And once again with respect to y. So uyy. E power minus y differential again minus e power of minus y. So minus minus plus e power minus y into cos x. So now I am going to add these two. So uxx plus uyy is equal to, this is negative term, this is positive term. When you add these two, it is 0. Therefore, u satisfies Laplace equation. This is the Laplace equation. So u satisfies Laplace equation. So next I am going to take v. So what is v? V is equal to e power minus x into sin y. Okay, so now first I am going to differentiate partial with respect to x. So vx, e power minus x differential minus e power of minus x into sin y. Once again with respect to x. So vxx is equal to e power minus x differential minus e power of minus x. So minus of minus plus e power minus x into sin y. So vxx over. So next I am going to differentiate with respect to y. So sin y differential is cos y. So e power minus x into cos y. So next I am going to differentiate with respect to y. Once again with respect to y. So e power minus x into differential of cos y is minus sin y. So now add these two. So vxx plus vyy is equal to, this is positive, this is negative, so it is 0. So that v also satisfies Laplace equation. So v also satisfies Laplace equation. But the question is, prove that both u and v satisfies Laplace equation. So okay, both are satisfy Laplace equation, but u plus iv is not analytic. U plus iv is an analytic function or not analytic function. To verify analytic or not analytic, we have to compare with the CR equation. What is CR equation? Ux. So listen carefully. The CR equation is ux is equal to vy. So vx is equal to minus uy. Okay, so this is CR equation. Okay, now I am going to compare here. What is ux? This is ux. Okay, ux. Another vy. Where is vy? This is vy. You see, ux is not equal to vy. So from these two, ux is not equal to vy. Therefore, CR equation not satisfied. Therefore, CR equation not satisfied. Therefore, u plus iv is not analytic. So u and v are satisfies Laplace equation, but u plus iv is not an analytic function. Hence proved.